All right, our next panel is on the topic of risk management and AI. Our panelists today are David Koppe, the Director of Information Strategy at MongoDB, Dr. Jordan Brandt, the co-founder and CEO of Inpher, Ravi Bhatia, the Head of Global Credit Risk Oversight at PayPal, Michael Grant, Director of Technical Consulting at Anaconda, and Ruchi Gupta, VP of Credit Risk at HSBC, and Roderick Powell, the SVP Head of Model Risk Management at Ameris Bank. Please welcome our panelists to the stage.
Thank you and welcome everybody. I'm David Koppe, and as you can tell from the socks, I'm with MongoDB. I'm Director of Information Strategy, so we work with customers on how customers can use MongoDB and our technology platform for key operational innovative, disruptive initiatives, and obviously AI machine learning is a big player in that space. So I'm going to be moderating. I'll allow my co-panelists here to quickly introduce themselves.
Great, thank you. My name is Michael Grant. I'm the Director of Technical Services at Anaconda, and many of you may be familiar with Anaconda as the purveyors of the Anaconda Python distribution, or the data science distribution for both Python and R users that we have 16 million users, I believe. Last count, we have some enterprise products for IT departments that need governance and compute management capabilities in-house. I'm here, obviously, therefore, as a tool vendor and not necessarily as a domain expert, as some of the rest of the team. That said, that as somebody who's in the services industry, both at Anaconda and prior to Anaconda, I have experience with Markowitz-inspired portfolio optimization as part of my academic work in mathematical optimization. I have some experience with a company using machine learning models in novel options pricing mechanisms, and I have some services work with credit with a well-known credit card consumer credit company implementing credit decisioning models in Python. So hopefully I have something to add to the discussion on both sides.
Hey, hi, good afternoon, everyone. My name is Ruchi Gupta. I work with HSBC in the credit risk analytics space. I've been with the bank for the last 6 years, and before that, I used to work in a startup analytic company, and before I used to work in a telecom domain. I started my career with a company called Motorola, in case you might have heard of it. And yeah, I'm a career switcher, and differently over the course of my career, I worked in a lot of cutting edge technologies, and I'm happy to share my opinion with.
Hello everyone, my name is Ravi Bhatia. I head the Global Credit Risk Oversight function in PayPal. My role right now is to oversee the development of credit products, their ongoing monitoring, and leveraging the machine learning and all the advanced models which are used in the decisioning for credit products. Before joining PayPal, I used to work in American Express, where my experience was in the similar domain. I've spent all my career so far in credit risk, analytics, and similar domain. I'm happy to share my views in this panel.
I'm Jordan Brandt from Inpher. We're a secret computing company that does privacy-preserving machine learning. What that means is that we can compute data or allow our customers to compute data while it remains encrypted. And one of the big applications for that, and I think why I was probably brought to the panel, a lot of our customers are financial institutions that use this for credit and risk modeling. So they're able to compute and compliantly compute on distributed data sets without exposing any of the private information that's contained within it.
My name is Roderick Powell. I work at Ameris Bank. I'm in charge of model risk management. Before this role, I spent 6 years at KPMG as a director, and my area expertise is model risk management. And lately, a lot of the models are starting to use machine learning and AI type technology, so they're falling more and more into model risk management.
Great, thanks everybody. So the main topics we're going to cover today, obviously AI and risk management, but specifically around the areas of credit risk, operational risk, data considerations, model best practices, and so on. But let's keep it interactive. We'll definitely take questions probably towards the end, but if there's any questions that anyone in the audience has, please speak up, and we're happy to take those on. So first topic, credit risk. Ruchi, maybe you could just share some thoughts on how AI can play in that space, and also because AI and machine learning is such a rapidly developing industry, how that's changed over the last few years and how you see it changing going forward.
Yeah, thanks, David. So basically, definitely AI has a lot of potential in terms of improving the risk models. Like a lot of times when you use a conventional model like the linear regression or the logistic regression model, you are able to capture the linear relationship, but sometimes you also want to look at the non-linear relationship where the AI models, the machine learning models can actually help you a lot. But being said that, there's also a con, I should say, which comes with respect to the fact of the explainability. Because a lot of time these models are considered as a black box model. So that's one of the challenges which as I think some of the other people mentioned in the earlier presentations in the morning, that's one of the things which has been faced across the industry as a whole.
Great, that's helpful. Ravi?
Yep, so I just built upon the point around explainability. So this explainability sometimes not even to regulators, it gets challenging even for internal audience as well. Sometimes it gets very challenging to like, why the outcome is something like that, like why we are coming up with a solution like that. But there are some approaches, for example, I've seen people following in my current employer as well as in my prior roles. First is to have a more like in-depth knowledge about the technique, and the way many people describe it as that you should be able to explain the technique in plain English, like what does KNN, like K nearest neighbor mean, how does this work? You should be able to explain it in plain English, and maybe if you're in an elevator, you should be able to explain it in like 30-40 second pitch. So that's level of understanding as an end user you should have. Second area that people kind of work on is to look at counterintuitive cases. For example, when this risk seemingly looks low, but the model gives seemingly different outcome. A very specific example can be that, let's say the FICO is 820, but your PD-based models gives you a very high risk. So why this is happening? What inputs are going on? Why the outcome is off? So those are the kind of things we kind of look at from a day-to-day perspective.
Great, okay. Roderick, any
Yeah,
thoughts?
now most banks are working, if they haven't already developed, these CECL models, which is new in banking. And before, most of the credit stuff was based on regressions trying to predict losses. And what makes machine learning unique is that it's built to use a lot of data. And one of the limitations, if your organization doesn't have a lot of credit loss history, a lot of data, then you can't build a robust model that goes for machine learning or any type of algorithm. So one thing a lot of the smaller banks, and my bank is more mid-sized, Ameris, is data challenges. And if you don't have the data, where do you go to get it? Where do you go to enhance your data? So you can use these more advanced algorithms that need a lot of data to get good results. And so that's one of the biggest challenges. And what I see a lot of banks doing is using peer. If they don't have their own data, trying to use peer data. But to really get the most out of machine learning, you need to have a lot of features and loan level data. And in order to do that, you have to have your own data. So that's data limitations is one of the biggest shortcomings that I see a lot of banks have when it comes to really using the more advanced analytics for credit risk.
Okay, that's a great point. Yeah. So Jordan, you and I were talking about the need of AI and machine learning to incorporate data, and I know you had some thoughts on that topic as well.
Yeah, I mean, that's where we see a lot of our customers is the ability to aggregate more data, both across departments and jurisdictions as GDPR and other privacy challenges come up, but also with other organizations. So with regional banks being able to combine data without giving up any of their confidential customer information is a big application. Also in emerging markets, we see a lot of applications across industry. So banks partnering with mobile providers, with retailers to get a deeper and broader credit history, more features. Again, without exposing any of that information because they don't want to give up their own customer information. And conversely, the mobile providers and others can use that data for marketing models as well. So there's benefit for all those groups to be able to get together. And the other interesting thing when you get more data, you can also use simpler algos, which are more explainable, right? So you can continue to use the same algorithms that you've been explaining to the regulators for decades now, and still get better predictability because you have more data trumps better algos any day of the week.
Interesting.
Yeah.
That's a great point. So yeah, I mean the topic of explainability I know is pretty key. So Michael, that sounds like a tooling problem. So I know as not necessarily a tooling problem, but certainly something that tooling can assist with.
Well, absolutely. I mean, I think one of the things that the Python ecosystem provides rather richly is just fast access to the latest algorithms and the latest developments from academic research and so forth. And I do feel that explainability, particularly in advanced models like deep learning models and so forth, is still an area that needs to be explored at that academic level. Even the work that Jordan's group is doing, for example, is really cutting edge in terms of academic quality. But I think I wanted to touch on something that was said earlier just by anecdote. Jordan talked about how in emerging markets they could, say, partner with mobile providers. Well, it reminded me of an anecdote in the credit experience that I had where in the United States, of course, the credit decisions are regulated by civil rights concerns and so forth. Even asking the question of whether or not you have a landline is a potential violation of that because it turns out the machine learning algorithms often use that as a proxy for age, right? Which is a protected demographic, and so you really do have to be careful in at least in the United States and other highly regulated jurisdictions before you start to look for alternative sources of data.
Yeah, that sounds like a really interesting challenge that everyone's favorite topic is regulation, obviously, but the variety of regulation around the world that it almost seems like you may have sort of a polar opposite of what's required in one country may be prohibited in another. How do you go about factoring that in? Any open enough for anyone to respond to that?
I can just share my outlook because I work in an international bank, so obviously we have to comply with different regulations. So when you build the models, the idea is to at least you have to make sure your model comply with the different regulations in the different countries, which obviously comes as a challenge because sometimes you might something extra, something different, which is, it's always a challenge to comply, to make sure that your models comply with the regulations across different countries.
Yep, and I can share some prior examples. So sometimes we make global models based on the attributes which are acceptable across all countries, and then have market-specific rules on the variables that you can use only in those markets. That can be one like a shortcut approach.
Yeah, makes sense. Any?
I'd say we should also not lambast the regulators too much because in many cases they're leading innovation. I mean, the Financial Conduct Authority in the UK just ran a tech sprint on new privacy-enhancing technologies. And what does that mean for things like fighting financial crime, building risk models? So they see the value in this, and in many cases they're trying to find ways to encourage financial institutions who often to vendors use that as an excuse. Oh, well, we can't use it because we don't know what the regulators are going to say. So in many cases, they're becoming educators of markets.
Being more prescriptive in best practices.
And the model risk-based regulations are kind of lagging behind. We have what we call SR 11.7, which I'm sure a lot of you are familiar with, and governs model risk management. But it was those regulations were developed, 7-8 years ago. So things have changed since then. And so I think that we do need, more updated regulations that's keeping up with the technology, AI, and machine learning. And so hopefully that will be forthcoming. And I have heard some chatter. Some regulators are saying that they are going to come out with some guidance on AI. So I'm looking forward to seeing what that guidance would be.
Yeah, that's great. I know one other topic that I think we've sort of touched on is this challenge of sort of domain expertise, right? So do you hire people who are familiar with the domain, familiar with the technology? Any thoughts there? I see nods heading.
Yeah,
Absolutely. I think every one of us has something to say about that.
You need both. You need the technical skills and you need the domain knowledge, especially with some of these techniques. Especially unsupervised type of learning situations, even old-time PCA, which is called machine learning now, but decades ago they weren't calling it machine learning.
Linear regression is machine learning now.
Absolutely.
Exactly. So if you have PCA and you come up with these components, you need domain expertise to put a label on the component. So even if you can hit a button using Python and run something, you still need to be able to label your outcomes. And you need domain expertise for that. So you do need a combination of people who have good statistics, good computer programming, which is not that hard anymore, thanks to Anaconda, but also have expertise in the area that they're trying to solve the problem for.
I'll pass this 20 along. If I can speak to this a little bit, though, just the challenge of attracting proper talent in data science and machine learning. It is such popular field to get into now, that a lot of people are jumping from their current fields into boot camps and online courses and correspondence courses to develop their skills there. And I think they're going to come up short, flat-footed, if they try to get into some of these very specific fields. And I would say that if in the chicken or the egg problem, I think the domain knowledge should come first. And so if you have people with significant experience in the domain, but they need to develop their expertise in the modern machine learning methods, that's probably the better order of events. Yep. And not only that, I mean, I've been around long enough to remember, when it was just traditional portfolio optimization and quantitative analytics, that the strategy was to hire people that are extremely skilled in analytics and then immerse them in the domain specifics of portfolio design and just see where they run. It was a little Darwinian, if anything, but in this case I think it's different because the domain knowledge is so important for risk management that I think that's the proper order to go in.
I mean, domain specificity is necessary to differentiate between causation and correlation, right? There's even some theories in the general AI that's what differentiates us and what general AI will provide. So,
right. If I can just add, I think having a domain knowledge really helps you understand does this results really make sense, and especially when you try to do a feature engineering, you try to build some features. It could happen if you just pick up some random, touching upon the causation and the correlation part, you might use some random variable and you might get a very good results. But this variable, does it really make sense? You just got it like that, or it really had a really reason behind it. So having a domain knowledge really helps.
Right.
So domain knowledge can also help you, like calling a spade a spade. Like I've seen, for example, models which use FICO as an input, but the outcome is worse than FICO. So then why this happened? Do you use like the best available technique, best available data sources, but something was wrong in the conceptual soundness, or like some problem happened that resulted in that kind of model. That can only be fixed if you know what the outcome should look like and what the outcome is. That there comes like the higher weightage on the domain expertise.
Interesting. Yeah. I think I was reading yesterday an article saying that in sort of the AI, machine learning, and data science space, unemployment of resources is around 0% because there's such a demand of those type of resources. Which on the consuming side of that, that's if you're in the field, that's a great thing. But if you're looking for those resources, you may not have that much of a choice of the best type of resource to pick. So.
Well, in the specific issue of training, so again, let's say we want to invite someone or encourage someone into a boot camp or some sort of correspondence course to expand their knowledge in this area. One of the things that you want to really be looking for is a course that emphasizes the mathematical underpinnings of machine learning. Because this gets back to both explainability and calling a spade and recognizing causation and correlation. A lot of the boot camps are maybe focused on machine learning as a black box, as a set of software packages that, as much as I love being able to provide, you need to understand to use properly. And other courses are significantly stronger. I'd say, for example, the Lambda School has a very mathematically focused course on data science, and there are others out there. So I think that's just important to tease out, is that I think we've agreed in previous discussions, the mathematical sophistication of your data scientists really does matter.
We filter out, data science applicants, and for us, like we're translating the algorithm into cryptographically secure protocols, and it's very important to understand the underpinnings of how it works. And if we don't see that they've had linear algebra, it's a disqual right away.
Right. Yeah, makes sense. I think one other topic that I think we all mentioned as we were chatting before is model bias. How do you protect against that?
Well, I think that there are areas where tooling can help here. I think model management has multiple definitions, but one of those is that a model that's already committed to production, being able to monitor its performance over time as the demographics of the input data sources drift, make sure that it doesn't fall out of compliance. So having a sort of, I would say, from my point of view as a software provider, what I want to provide are effective tools for monitoring, for reevaluating models on newly created historical data, as the recent data becomes historical, to be able to build dashboards that let me visualize that performance degradation over time, to set notifications and other flags and alarms when they are out of spec. This is something that some of the old guards in this space, like SaaS, do well, that the open source space is still struggling to master.
Okay.
Yeah, I just want to add, the bias has nothing to do with the AI or the machine learning models. It's the issue which is with any of the models which we use. So if you are using a model which is based on, for example, pre-recession data, and you want to see how and you're forecasting based on that, obviously the whole financial industry has changed since 2008. So your model might or might not behave exactly the same way. So as Michael pointed out, it's also very important to keep testing your model on the new data and see if it's, basically your goalpost has been changed. Initially you're targeting towards this, but now your whole goalpost has moved. So you have to make sure your model is probably recalibrated with the new data or probably redeveloped based on the new data.
Yeah. So sometimes in my role, I've seen like model, while overseeing the model, not developing the model, is that the model is built on population A and is applied on population B. It's like a clear modeling model validation 101 issue. And this happens many times in the companies where it's growing very quickly, you're exploring new segments, new products, and kind of building something here and kind of applying there. It happens very little bit less on when the company is not growing very quickly or the portfolio is largely stable. A part of it that can be solved by having like a very stronger risk culture that this model makes no sense to apply to that particular segment. Either you kind of be more conservative in implementing those models, or maybe not using the model at all. So those are the kind of things. It seems.
Which I guess is also where domain expertise comes in, knowing what you knowing what you should know, not necessarily not knowing what you don't know.
Yeah.
And you can build those into your models. So if you know that, if you have domain expertise and you know that this period of time is different from this period, and there are regime shifts, you can use categorical variables depending on what algorithm you're using to make sure that your model is appropriate for the time period or what you see in that particular environment. So there are some advanced things you can do to take that into account in the structure of the model itself.
And also just fighting bias. I mean, if you're only training your model on your own institution's historical data, then you're going to inherently have the bias of your institution. So being able to combine cross, departmental, cross-organizational models is very important, I think, going forward, because there is increasing regulatory ask for, showing and being able to explain that your model isn't drifting over time and is not developing bias. And the way to fight that is get more data into your model.
Yeah, I mean, I think doing some kind of a benchmarking obviously helps. Like there is the same kind of banks, the same kind of industries, you can see where does this performance lies versus what you are predicting. So if you are way off, there is something wrong in your model, unless your practice is entirely different what the other company is doing in the same domain.
Okay, makes sense. This seems like a very important topic, the model management and ensuring that it's accurate over time. What other challenges and solutions have you found in that area?
So for us, what we do is we do a more ongoing tracking of the outcome, as in have a clearly defined milestones, and check if the objective function is aligned with the way the model is getting used. And if there is new data source getting in, then kind of rebuild the model, especially because all the new models current models that are getting used largely are based on the very recent vintages, which are way far off from the prior recession. So how do you train them? How do you evaluate the performance, and then kind of make the changes as and when required?
Yeah, one thing we test, I work mainly on the stress testing domain. So when we look at our models, we also looked how did this model perform historically on the back testing. That really helps us realize are we actually missing some points or something else needs to be done on that.
In my experience with this, the models are continuously being evolved, not just on newer data, but even mining historical data for again new demographic subsets that might provide a feature of use. And in that case, there's an operational issue at play there. How do I coordinate the collaboration of, say, multiple business analysts analyzing mining for additional features, and then incorporating that into the model, and then verifying that those changes have only affected the identified subset or the identified improvement, that the intent of the model is reflected in the actual coding of the model. And so what's worked for us was to to draw as many best practices from classical software development as possible, including even, for example, using GitHub pull requests to manage and document the discussion around an actual model update. And using package management strategies such as we do in Anaconda Python packaging, for example, package management strategies for ensuring that you have a reproducible model with all of its dependent software packages. So again, pulling the best practices from software development into model management proved to be pretty effective for us.
Interesting.
At my bank, what we try to do is that the developers or the model users should constantly monitor their model and how it's performing. And then my team, the model validators, come in after that. We can't constantly monitor their model, but we come in, maybe once a year. So it's a team effort. The developers, the users, the validators all have to make sure the models are operating, as expected. And what we've done at Ameris is we looked at all our models in our inventory and picked out the ones that are using the advanced analytics, and we give those special scrutiny. So if I see anything called neural networks, for example, I set it over here. If I see k-means clustering, I put it over here, and those get a higher tier.
Yeah.
And so those are scrutinized even more closely than just the traditional linear regression models.
Yeah.
Do you do that all internally? I'm wondering, because we've had an influx of third parties, whether it's startups or the traditional accounting firms, offering managed services for model validation and model management. I'm wondering, is this something, it seems pretty close to the heart for financial institutions, but do you use both and or either or?
Yeah, I mean, it depends on the size of the bank. Some banks, even bigger banks use help. So, it's a combination of in-house resources and consultants. Because, for instance, our bank, 70, 80 models, some banks have hundreds of models. So it's impossible for, to have an internal staff. Well, B of A has a pretty big staff that can actually validate all the models. So people usually use a combination of in-house resources. And if there's an area of expertise that you don't have in-house on a particular type of model, for example, some of the stuff that I mentioned, then you would have to go out and get an outsider to help validate the model for you, to help you.
Yeah, we also follow similar approach, just that we add one more layer of materiality. Like, is the model material enough in terms of outcome?
Right. So, shifting gears a little bit, I know one of the other topics that we talked about is operational risk. You share some thoughts on that?
My experience is mainly in credit risk. So.
Okay. And
well, I think if I remember correctly, and I believe we've partly covered this already, when I talk about operational risk, we talk about things like managing the model management workflow, the model approval workflow, the model validation, and then of course the subsequent historical or the subsequent kind of monitoring of a production model. I think all of those, there's potential for flaws and errors in all of those steps, and I think so. That was, I think we were talking the general category of operational risk is referring to all of those kind of non-mathematical aspects of the management process. But somebody could correct me if their memory's better.
Well, if you look at it from a standpoint of credit risk and market risk and operational risk, the operational risk covers things like fraud detection and anti-money laundering, cyber security prevention, and so those types of we basically classify those as operational risk models. And those are really important to financial institutions. And then make sure that no one's funding terrorist money through your organization. So that's where I'm seeing the most application of these advanced analytics, the clustering algorithms and so forth, is people trying to identify the anomalies. And because historically most of the models were rule-based for fraud detection, and but so you would capture a lot of transactions that were not fraudulent, but you would capture them anyway. So someone had to do the research. If you say these 100 transactions look iffy, they may be fraudulent or whatever. A human has to go in and check. And a lot of times the models will overshoot. So with these new clustering algorithms, you can get more precision and less false positives. So that's one of the real use cases that I've seen in the banking industry for using this technology are the fraud detection, anti-money laundering, terrorist financing, trying to identify all those types of things, those money flows that could come through your organization.
If I could ask a question, I'm just curious if those are areas where the explainability problem is less important, and if so, whether deep learning is something that could be more readily adopted in those particular areas.
I haven't seen deep learning used there. I mostly use C clustering.
Sure.
Because you want to group all types of supervised and unsupervised, because you're trying to figure out which transactions are valid and which ones are fraudulent.
Mm-hmm.
So, those algorithms are easier to explain than neural networks. So thank goodness, because we have at my bank we have those tools. So we do have software that does actually use clustering algorithms and so forth to try to find those types of problems. And they're easier to explain than
Understood.
Yeah, like graph analysis. Yeah, you can basically understand how many levels removed there is connection. But we have seen the regulators, not so much on the explainability, but about liability. So in these scenarios, whenever they're investigating if there was fraud or some money laundering or even insider trading, let's say in models that are identifying those scenarios, the regulators currently, you have to give the data to them for them to run the forensics. They don't want to take on the liability of seeing that data unless they know there's a bad guy there, right? And that's why they like the idea of having a privacy layer such they can run their analytics and their forensics with their own algos to see if it matches a previous pattern. And if there is a red flag, then they can subpoena the data that they need and not take on unnecessary liability.
Right, makes sense.
But also the operational risk thing is the risk of the input into the models itself. I think that risk profile has expanded a lot. We've seen many recent examples of this. I won't name names of certain banks, but that have been caught on the bad side of not properly addressing that broader attack surface that has appeared.
I think we agreed not to name names,
No, that cybersecurity is a big area. I see a lot of potential to use advanced analytics to keep companies from being hacked. And
no bank want to get it into a bad headline on anti-money laundering associated with them. Not even like a fintech. Like recently we saw one Australia-based fintech who was into point-of-sale financing that got into that bad headline, and the outcome was their market cap reduced significantly.
Right.
So people started doubting their entire business model per se.
Yeah, it's one incident like that, and it's very difficult to re-establish a brand. Yeah, absolutely. So on that topic, the fraud detection, is that presumably that's moving more and more to the real-time aspect as opposed to the batch. Is that in terms of the tooling that can help in those decisions? Where do you see that going? We were talking earlier that a lot of folks say, hey, there's been these amazing advancements in AI and machine learning in the last few years, and a lot of it really has just been the culmination of the algorithms and the logic from decades ago. Now we have vast amounts of compute and data that we can apply those algorithms to. So it's more of sort of the availability of technology that has driven that. How do you see that changing and growing? Obviously working for a software vendor, we want to understand what capabilities the industry needs, so that we can move in that direction. Obviously, Michael, I think you would agree on that topic.
Oh, absolutely. Right. I mean, and I mean, I think the thing is, for the good news for real-time machine learning is when we're talking about the real-time aspect, it's almost typically the scoring in an arena, which is generally going to be computationally less intense than the training and the model discovery and the iterative process. So I think the news is better for real-time machine learning there, but in terms of the specifics of what our colleagues here use, I'll have to defer to them.
I don't work in operationalists, but I think generally from a broader, I think definitely having a real-time data especially with the huge computing power which all the machine learning algorithms can run on, having a real-time data really helps a lot because it helps you catching a lot of fraud cases immediately. Otherwise, your people have to sit on the tons and tons of data and try to figure it out.
Oh, so the amount, if you're doing it in real time, you don't need to hang on to the data. If you're doing it in retrospect, then you need potentially years of that data to do the
right.
analysis.
If something wrong is happening, you want to catch it as quickly as possible. You don't want to wait it for a day even. So if you can do it real time, definitely it helps, I assume.
Yep. It's getting used in real time. As far as I remember, was that even in authorization decision for credit card transaction, all the decisions are done in fraction of seconds, and that uses advanced machine learning models. even on the loan amount determination, the credit limit assignment decision, they use like machine learning models, which leverages like data pulled up from multiple bureaus and application data, and all the decisions are done on a real-time basis. And even when you apply for a credit card, you go to any website, they usually say that the decision is done in 60 seconds. And at the back end, you have PD score, you have like the credit limit determination, pricing determination. One model feeds input into another model, and eventually you get an outcome, and all done in real time. Many of these models have evolved over time, started with regression-based model. Now, from my prior employer, I totally remember many of these were like totally machine learning-based models like KNN and GBM models.
You know, as Roderick mentioned, that some of the new algos that are being deployed, especially in the anomaly detection, now are not just memorizing those; they've been able to generalize and therefore reduce the false positives, which I think have been a lot of the challenges around doing any kind of real-time reaction to fraud. So we've definitely seen an adoption of more sophisticated algos that can do anomaly detection and aren't, you don't need as large of a back office necessarily now to process all the false positives.
Yeah. One of the problems I see, a lot of banks and institutions are not developing their own software to do this. They're using vendors. So when you have vendors, a bank or financial institution, we have a vendor that supplies the anti-money laundering software algorithms or whatever model, or the fraud detection model. And then you have a different vendor that has the data. So you have to try to get the vendors to talk to each other. So you have a data provider. You have to work with them to give the data and make sure the transactions are going to the vendor who's actually developing and implementing, the model to detect fraud. So you have various vendors that need to work together to make it happen. And I have seen some bottlenecks where trying to get people all fintechs to work together in harmony to actually get the client the result they need.
Funny, we've seen challenges getting banks to work together in harmony.
So data provider and model provider can be two different companies.
Yep.
And they have to be able to work together.
Yeah, it's not easy to get that thing done. I totally agree. If you're thinking about like having a bank statement analyzer tool where we'll leverage some startups' bank statement analyzer capability, basically we pass on the bank statement to them. They will create like intuitive variables like number of NSF transactions or like inflows, outflows, and all these will be done through APIs, because we thought that if we build it in-house, it will A, take a lot of amount of effort, and B, maintenance of that will become like another effort. Then building those pipes, getting the data quality, ensuring that data privacy is maintained in a banking environment takes a significant amount of effort and time. Yeah. And sometimes it takes such a long time that people might even give up in the journey.
Interesting.
Yeah, I think at that point probably the domain expertise came in. When you're getting the data, you want to make sure it's really useful for your model. So that's the point where we just talked about the domain expertise that comes in.
Right. Yeah. And that actually brings up a really good point. You were saying, Jordan, about how more data is better than a more complex algorithm, but you've got this inherent restriction on privacy, right? Yeah. So I don't necessarily want someone having too much of my data to make a decision. How do you handle that sort of conflict?
If only there's some special technology that allows you to compute it while it's encrypted, right? I mean, that is the big restriction a lot of these times in combining more data sources. And so addressing that directly to say you don't actually have to share the data to be able to get the insight that you need. But then that often brings up the question of validation, which we get a lot, like how do we verify? And fortunately, there's now zero knowledge proofs that we can use independently to mathematically guarantee the accuracy of that output without actually revealing what those inputs are. Now, the challenge then comes into, well, how does this stuff work? And I would like to say, well, it's really simple, but it's not. So hence coming back to the regulators and really focusing on them, first of all, them seeing the value in it for their own use, which encourages them to learn more about it. And then it makes it easier for the banks to say, hey, here's the technology, here's how we can prove that it works.
I have heard some auditors, some auditing firms, and some consulting firms, and even some regulators push back on the use of other people's data to do your modeling. And people typically want you to have your own data, if you're, especially for like credit risk or whatever, as opposed to using just an amalgamation of data from a ton of banks and peers or wherever. It's harder to justify it's easier to justify using your own data than, you have to say, well, I'm using these 10 peers are just like us. So you have to, so I have seen some pushback on people trying to use, aggregated data as opposed to their own data, unless they have a really good reason. Maybe they've been through a lot of acquisitions and mergers, and they just don't have a clean historical data set where they can use their own data, and they have to use, other banks. But the preference is, use your own data if you can.
Okay. Yeah, I think the key point is what you mentioned when you say the data is just like us. If you can explain, that is the key point, is if you can explain what is the meaning of just like us, can you actually proof it to them, then it's really acceptable.
Right.
Basically, it's logical peer. How do you define that our performance profile is exactly similar to that peer? Yeah.
If you have a loan category and you've never seen a loss in it, obviously you have to use, the regulators won't just say, okay, we'll never have a loss in the future. You have to use someone else's data that has had losses. So they really do want, a good explanation of where the data comes from, why is it relevant to your modeling situation.
Great. I want to go back to the topic of explainability, which you just alluded to. What other ways does explainability manifest itself? In terms of sort of, if a regulator wants you to be able to explain a model, obviously where the data came from, the logic applied to it. But when you get into sort of machine learning, deep learning, where there's there's a little bit of a black box in there, how do you balance those two things? I guess that's a technology question. So,
well, I'm actually not sure. I mean, it depends. It depends on the type of model they're building. I mean, for example, when I worked with with a hedge fund that was doing novel options pricing, they were using, whatever machine learning algorithm that they could pull off the shelves and gave them better signals than their competition. And to be perfectly frank, they didn't have to care. I mean, they let the back testing prove their performance, and it was effective. They weren't encumbered by the same questions of explainability that a credit decision model is going to have. And so I'm not sure it's a technology question.
Okay.
Yeah, I think I can just provide my input. So definitely, if you can provide more explanation to the whole, thanks to all the Python and we had seen all the technology advancement which has been happening, which really helps in visualizing how the things have been actually been moving. Okay. And the other way to do it, probably I will say, see the certain trends I cannot just capture with a normal linear regression model. Probably if I use something like an ML or AI technique, I might be able to capture. If you can provide those kind of things to the regulator, I think it's definitely more acceptable than starting from the scratch, I should say.
Okay, makes sense. On the topic of regulation, I think Jordan, you outlined the idea that a regulator can actually be defining best practices and leading the industry. Do you see that happening?
I don't see necessarily the definition, but definitely the encouragement to explore and saying that, hey, we're not the holdup here. We actually have value in consuming the new technologies in their own applications and making their own operations more efficient. And it also helps them have greater oversight into the community. So they're never going to be, I think, explicit in saying do this or that. At least in our experience, we haven't seen that. But we are seeing a groundswell, and unfortunately, I would say the U.S. we've seen it a bit, but more often it's in other markets that we've seen them kind of leapfrog. In a way, in emerging markets, I think are in a position to leapfrog a lot of the modeling that we're doing in the U.S. at least, because the regulators are more open. They're much more strict on privacy. I mean, they already have their own sovereign data privacy council, so they're including that by design into the regulatory requirements. So the U.S. is a little bit lagging there, I feel. Maybe the peers in industry could confirm or deny that, but that's what we're seeing ourselves.
Interesting. Any other thoughts, Ronnie?
I can just add in terms of I think we always, when we talk about the models, we always think we should be using machine learning models to probably develop something, but I think the other way to look at it is to just get more data. So use latest machine learning techniques, for example, NLP, the text analytics. So if you just get more data, probably with a simple linear regression model, you can get a better results. So that's one way I believe to get rid of this whole explainability issue.
So you, again, use the model that's already been explained, but just apply it to more data.
Right, because it's your own data at the end of the day, right? And
Exactly,
you
yeah.
know this data makes sense, and so it's easy, I believe.
Makes sense.
But to her point, sometimes you don't need to do a rocket scientist model to solve a problem. And you know, so
Then what are all these kids who are coming out of the boot camps going to do, right? That's right. They don't know how it works. They know if you put something in this side, then something else comes out the other side.
Yeah.
And it looks cool.
And the funny thing, a lot of what we're calling machine learning has really been around for decades.
Right.
Yeah.
I mean, it just has a new moniker, you know, more data. And that's really the distinction between a lot of these statistical techniques now and what we're seeing now is just you're applying the same techniques to more data. Really, it's only a few algorithms that are somewhat new, and that's when you get into the neural networks and deep learning. But all the other stuff, PCA, clustering, people have been doing those for a long time. Now you just have more data
Exponentially more
to
data
throw
to
at
run
it.
against. Yep.
And so I think as far as explainability, what I tend to do is if I have a model, you know, I can explain it in machine language terms. I can use the word features, you know, instead of independent variables, which is the old way we would talk about features.
Yeah.
So it's a different language, and I think part of the explainability is just to get over the language, the terminology barrier to machine learning. You know, cost function, you know, it's the same as, you know, it's just the same type of language just converted to machine language terminology. I think is a big part of explaining it to someone. And so when I talk to regulators, I talk to people inside my bank, I say, you remember from Statistics 101, you called this independent variable? Well, now we call it a feature in the machine learning context. So I take all the terms and, you know, explain them in the way that they could understand them from back in the old days.
Yeah, some of these can be directly taken from the, as we call, old days, that your FICO is so low, or like your too many inquiries, or like your bureau tenure is too low, which will eventually come out in the new set of techniques as well. But you can kind of pick up the key areas and then write in terms of like why the outcome is like that.
If only we had an AI to explain the AI.
Yeah. But you know, I remember when I first was exposed to this new term, machine learning, and I saw someone did a presentation saying machine learning, and then I saw the techniques unsupervised learning, and I saw principal components analysis, and I remember writing a paper on that 20 years ago. Right. I'm like, this is old. You know, this is really, this technology has been out there. Now it just has a new name, and it's getting a lot of attention. And we have and now we have big data as opposed to little data. And we, you know, we did not have Python back then, so that helps a lot too.
Sure. Well, no, I'm really glad that we're talking about it like this, because I think maybe it's a little politically incorrect at a conference called AI4 to drive home the point that at the algorithmic level, the innovation has been relatively minor. That, for example, with deep learning, they've been doing I mean, I think that first came out in the 80s, maybe even in the 70s, and Bernard Woodrow's neuron model, but it was with some minor adjustments like the ReLU cost function. It's the ability to process significantly larger amounts of data, the ability to do massive hyperparameter searches on distributed computing. That's what has enabled the power of these algorithms. And yes, the results have been scary looking sometimes, and there's been a temptation to ascribe intelligence that really is not there. I think the popular sentiment of AI is that it's a lot more magical than it really is. I mean, the wizard behind the curtain is the same algorithms that have been around for a long time.
Right.
And maybe that the better we can advocate for that story, the easier it's going to be for us to convince regulators and the public to embrace these kind of modern
The
algorithms.
explainability is a lot easier when if it's a technology and an approach that's been out there for a long time.
Sure.
Then it's a lot more explainable than if it's something new that the perception might be nobody really understands it.
And I'm sure there are grumpy statisticians all over the world who are screaming, "We've been doing this forever," that would love to help us with that.
SAS and MATLAB.
Yeah, I see terminology being a big part of the issue with machine learning and AI, just getting good definitions out to people, a good lexicon, and I think that'll help with explainability quite a bit. And because when people think of AI, they just think of androids and robots, and it's
And the Terminator,
that's not
right,
that's the only thing to AI. There's a lot. It's a very broad subject area, and we are actually using it. And it's just not the robots taking over the world yet.
Right.
It can't even label my
Just
cat
clustering.
properly, you know?
Yeah. Yeah, just an algorithm that determines is it a cat or a dog. You know what I'm saying?
Right.
So we have around 10 minutes left. I do want to open it up for any questions in the audience. I think your hand went up first, sorry, and we'll get to you in a second.
So we got the topic of model risk management in banking, and Roderick pointed to the SR 11.7, the Federal Reserve requirements, right?
Yeah.
Now, in November 2018, Federal Reserve published a document where they specifically said if banking is using any kind of AI or machine learning models, the starting point should be the model risk management, the SR 11.7 requirements.
Yeah.
They don't have any kind of prescription for that. In December 2018, there was another paper from a different Federal Reserve with Financial Crimes Enforcement Network that you should be actually innovating in certain areas. And in that 5-pager document, they use the word innovation 26 times. Now, this seems like self-contradictory. One place you're saying, okay, you should comply with SR 11.7. Other place you're saying you should innovate. How do you handle this challenge? What are you seeing from the regulators? How they are kind of questioning you on these two different kind of angles?
I think it's the same thing that happened with blockchain, where the regulators were saying we're going to be hands-off, but we're going to be hands-on. You know, they selectively decide where they're going to enforce actions and where they're going to promote innovation. So I think the regulators are still trying to get their arms around this AI and machine learning world. I think that's why you see. But like I said, the SR 11.7 is very old guidance. And I think that it needs to be updated and to include machine learning and AI applications. And they just haven't done it yet. And I think that'll clear up a lot of the problems.
Yeah,
I think you also just have to focus on areas where it helps them. The adoption of the technologies help them in their job, and therefore they're going to be much more accepting and not prescriptive. Again, I don't think they ever will be necessarily, but there'll be less contradiction.
I think there's certain areas that they would not have a problem with. So like, for instance, preventing money laundering, that's a big deal with regulators. And preventing terrorist financing, that's a big deal. So if you're applying AI or machine learning to those types of applications, they do want you to be innovative. And if you're not, and something happens, they give you a big fine. But anyway, there's certain areas, they're a little iffy on other areas, like a computer saying, approve this loan or don't approve this loan based on the features of people that could, give you biased, answers. So I think that they're going to be selective, the areas that they want you to innovate in, and the areas that they want you to be cautious in, where there could be some bias creeping into the solution of your algorithm. Like, when it comes to approving loans for individuals, where, if you let your algorithm just run, it could just make all loans in one area of the country and not another. So there could be all kind of bias. But when it comes to stuff like detecting fraud and money laundering, I think they definitely do want improvements in that area. And if AI can help, I think they'll be all for that.
Yeah, I think I will just my interpretation of that thing will be they want you to improve your model validation standards, because since we all have been using the simple, normal, conventional techniques, all our validation is pretty much based on that. With the new AI techniques coming in, I think they might be expecting to probably come up with a different kind of validation, especially which are designed for the like AI or the ML techniques. That's my assumption.
So are they actually accepting these quantitative measures like LIME and SHAP, which are fairly new, but banks are implementing those? Do the regulators show acceptance to it or no?
I think to what you said, the regulators still want you to adhere to the SR 11.7, whatever techniques you're using. So they still want you to adhere to that. I think it's up to individual institutions to determine, like I said, at my institution, anything that's using advanced analytics gets a special look. I mean, we really look at it inside and out. So, because I want to be ahead of the curve. I don't want the Fed or anyone to come in and say that we're doing something that's crazy. I want to already internally, vet whatever algorithm or model that we're using before they come in and have a look.
Makes sense. Yeah, you had a question.
So, I think it would be very useful to hear about specific problems that people have either think where machine learning would work effectively, perhaps have not tried yet, or have tried, were successful, tried, and was clearly a failure, or if these certain areas are still being developed in markets. So there are specific examples. What specific problems have been tackled and were successful or failed, or perhaps you think should be successful, but have not tried yet?
Great question.
I can probably just provide my thoughts on that. Definitely text analytics is one field where machine learning, especially in finance, it has a lot more scope. Because if you look at all the speech recognition, everything which has been done by the Google and the other, it's a different kind of a text. But when you're talking more with respect to the regulatory requirement, or the banks, for example, they have the loan application, right? It has tons of data. I don't think there is a lot of should say helpful solutions have been provided. So I think definitely there is one field, there's a lot of improvement is definitely possible.
Yeah. So I can talk about from my own experience that where on the credit side, machine learning models have created significant amount of impact when it's related to acquisition, underwriting, or on ongoing customer management. These three areas, all the models I remember from by 2011-12 were largely regression-based model. But right now, all of them are either GBM or KNN-based models. So that's definitely an area where machine learning models have kind of created a significant amount of impact. But there are some fields where you don't require that much of sophistication. It can be as basic as roll rate forecasting. How will the delinquencies or write-off or will change? There, it's all based on older methodology of a segmentation and all. It's working fine, and you might not want to even innovate even on further. But one area that has kind of, we did not discuss in the panel so far is that use of new data versus new technique. Many places where you bring in new data, that ends up in adding significant amount of incremental value. Even if you use the old technique or the new, but the new data itself kind of generates significant discrimination.
Yeah. One area we haven't mentioned yet that is being used is in the chatbot world in banking because
I was kind of hoping that wouldn't come up.
The natural language processing, which I don't deal with too much in my job, but some banks like B of A with their Erica that you can call and get advice and I mean natural language processing is a big deal. And it's definitely an area that has been successful so far. Especially some of the bigger banks have implemented that successfully, and there are some. Obviously, there's a movement afoot to have people-less branches, bank branches, and things like that. So there are some areas that have been successful: the chatbots, and then the analytics, area, and then the anti-money laundering area and the fraud detection. Those are real, actual things that are being done now that's using this technology. Some other stuff is kind of pie in the sky. We're not there yet, but there are some real use cases, some things that are currently being done in banking.
Anomaly detection definitely in whatever category is one area where there's been a huge benefit. But another thing to think a bit further beyond is that we're talking within, but think of the value of the data that is all of your representative organizations in this room have, and the collective power of that data, and it's being underutilized. If you're only using it for banking services, I'd say it's underutilized for society. I mean, think of if you could combine your genetic data and your health history and your financial data of what kind of treatment recommendations that you could get. Now, of course, you don't want anyone to have that information about you. I don't think we're all going to send it to Facebook. At least I hope not, right? But assuming that you could guarantee the security and privacy of all that data, what else could we use financial data for? Right now, we're just talking about improving things that we're already doing. But what new things are untapped? What new opportunities are out there? Is where I would hope the industry is going to look in the future.
And I think the other part of the question is where has it failed or not been as successful as you would have anticipated?
Erica.
I think there's some, people are trying to make enhancements to what they're doing now, for just incremental enhancements, just taking Erica as an example at B of A. I mean, they're thinking about having a male voice and a female voice, so you can decide which one you want to talk to. So I mean, just little incremental changes like that, but I haven't seen any all-out failures, yet. I mean, outside of the banking realm and financial services, obviously, with the self-driving cars, we've seen some people die and so forth. So I mean, but in the banking arena, I haven't seen any just complete failures. I think people are just tinkering, trying different things.
So it's more a case of it's delivered, just maybe not as much as you hoped, so that you iterate on it to maybe improve.
Yeah, I think the loan area is one area that people are tinkering with. Doing automated underwriting, letting the computer just decide if you're going to make a loan or not. People are experimenting with that, and that is the area that I haven't heard of any big failures yet, but I can see that as being the area where a computer can just make a completely just biased loan approval decision, or more likely a denial that hits the front pages of the paper. You go in and do forensics and find out that the model is being just extremely biased because of some feature that you put in there.
That also is like your own mistake of putting wrong features versus the technique.
Well, just let the features go, just putting them in there. No domain knowledge, expertise, just throwing everything in there and let the model decide. That's where you can come into have some big problems.
Depends how you define failure as well.
I was going to say, there's a lot of big failures of the data breaches. I mean, the pooling, the idea that I'm going to take all of my sensitive data and put it into one spot is just dumb. And for most of these pipelines that people are building for the AI, that's kind of the default assumption is what we're going to do. So I think if maybe not the failure of the outcome of the AI, but the failure in the pipeline to build the AI, there's definitely been a lot of those.
Right, that's a great point.
It's actually on my mind earlier, somebody made the comment that you put FICO into a machine learned model, and the output is a worse predictor than FICO.
Right. That doesn't sound like a success to me.
Machine learning is littered with failures. That's the nature of the business. We explore a variety of prototype models, and we select the ones that win. I mean, it's the success of machine learning is the exception when properly executed, but it's the ones that succeed that get deployed.
Interesting. I don't know if can we maybe take one more question?
Can I just build upon that real quick? The notion that FICO is an accurate predictor is sort of conventional wisdom in the industry, right? So one of my questions is, remember that AlphaGo scenario where AlphaGo did something that none of the experts have ever done? Have you guys thought about how machine learning could be used to uncover sort of insights that the conventional wisdom within your space doesn't think of? An innovation that came out of machine learning that was unexpected?
This is why you need new data, though, because if you're using the same data, it doesn't matter what you're going to do, it's going to do the same thing.
I think
in that case where it did different than what FICO is predicting, is it possible that there's a better approach to FICO?
I think there could be, especially since you can take text and numbers now, and with the new Python, where you can use text and numbers and analyze text and numbers and not just numbers, because historically we all did our analytics based on numbers. And so there are some fields that you can bring in that you may get some new insights if you start taking the alphas, not just the numerics.
I would link it to the conceptual soundness of the model and the domain expertise of the people who built that model. It's not totally linked to the technique, it's the way it was constructed. Yes.
My last comment is I've never been happier that MongoDB has a Python driver. With that.
Thank you so much to all of our panelists. Let's give them a round of applause.